Very specific. This is trigonometry on vertical regarding vertical angles, right? How to apply trigonometry to questions regarding vertical angles. All right. So I'll start from there because I can't start the whole trigonometry. Teach you from the basics. Again, not the focus of the night classes. Right? Night classes focus for you to do questions. Right. So we'll learn how to apply our trigonometry that we know on vertical angles. I'll just give you a brief discussion about vertical angles first of all. All right. So now vertical angles is usual. Now when you look at a diagram, you can look at it in two ways. Either you can look at the vertical angle or the horizontal aspect, right? So then, for example, let's say you look at a building right at it, right? Let's say I'm standing straight here. In front of me, there is a building, and I look at it in a what? In a vertical plane, right? Let's say I have the board here, right? I look at the board here. If I draw a building, I'm looking at it at a vertical plane. So all the angles drawn or marked on a vertical plane are simply angles related to vertical plane, right? Now, when you look at the vertical plane like this, right? Now, for example, you have the horizontal ground here, right? You have a horizontal ground, right? Now, let's take a building here. Right now, usually, if you take, they don't mention this in your question, but it's general knowledge, right? All the buildings, let's say there is a telephone pole or any pole to the horizontal. Remember, now building is never slanted. Slanted buildings making history, but we're not talking about them. Usually, generally, the principle of architecture is when you make a building, the building is always perpendicular to the ground, right? A pole, whatever, is always perpendicular to the ground, right? Perpendicular means horizontal, and the relevant building or the pole is 90 degree, right? Now, when you look at a vertical plane, right, like we discussed in class, we said that there are two types of angle formed in a vertical plane, right? Now, if you take an example here, let's say a man is a few meters away from this building, right? Now, we always take a reference point, right? From the point where we measure the angle from, right? Now here, if it's a man, we take the eye level. A man looking right at the building or right at the building, that's the eye level of the man, right? So now we can measure the angles above the eye level, or you call it the word horizontal. We use the word horizontal. Okay, so this is the horizontal. So we can measure the angle above the horizontal at a certain point, and we can measure the angle below the horizontal at a certain point, right? Now, if this man is looking at the top of the building here, right, you can see from the horizontal, he's looking upwards, right? He's moving his head up. He's looking straight here. From the horizontal, he's moving his head up here to look at what a higher level above the horizontal, right? Now, same thing here. Let's say a man is at the top of the building. This is his eye level. Let's say there's an object here. Now what he'll do to look at the object, he has to look down from the horizontal, right? So he has a horizontal level. He has to look down from the horizontal, right? So two types of angles. From the horizontal, if you are looking up, it's called the angle of elevation. Simple. Elevation, you're elevating your head, right? So always from the horizontal, you're looking up, moving upwards. That's called angle of elevation, right? Again, from the horizontal, if you're moving down, that's the angle of depression. Remember, this horizontal is the point where we measure the angle from, right? So from the horizontal, you measure. From the horizontal, you measure. Always you need a horizontal to measure the angle, right? Now, usually in your questions, we don't consider the height of the man or whatever. Usually, we don't consider the height of the observer, right? So if you remove this person, the height of the observer is neglected usually. So that means now the observer is somewhere around here. Let's say this is the man here, right? The height of the man is ignored. This is the man here. Now from here, see, he is looking at the top of the building. right? From here is looking at the top of the building here, right? Now the horizontal level becomes the ground level. The ground level becomes the horizontal. From the ground level, you're measuring upwards. This is your angle of elevation. Same thing here. If the height is neglected. Now the man is somewhere around here. Now again, we mark the horizontal level. See here, the man looking forward, then looking at the object here. Now this is your angle of depression. So angle of elevation, angle of depression. Is everyone clear with angle of elevation and depression? Remember, you always have horizontal. If you look up, that's your angle of elevation. From the horizontal, you look down, that's your angle of depression. Is everyone clear with that? Yes?
Yes.
Yes.
Yes, sir.
Right. Okay, now we'll get to the question and we'll draw a sketch to the question, right? So whenever you get a question, right? Whenever you get a question regarding trigonometry, the first thing is for you to draw a sketch. A sketch means when they give you the story, the case scenario, mostly it will be a story, you have to draw the relevant diagram, just an idea regarding the story for you to do the question, right? Now, most of the time, this diagram without the information marked is given to you on the paper. Usually, not every time. There are 1 or 2 times where they have not given the diagram in the past 10 years, but usually diagram is given. You can see all the three questions that I've sent you. They got 3 past papers, and all of them, the diagram is given to you. Right now, on this diagram, they have not marked anything, no information marked. Reading the question, you should be able to mark the information on the diagram itself. Right. I'll quickly draw the diagram here. Diagram given to you on the paper. Right. Right, this is the diagram given to you. Right, read the question, get a better idea on the diagram. Okay. Now, Amal, from the window of a vertical building, and Sumit from the window S of the vertical building. Right. So Amal is here. This is the vertical building. Amal is here. Now you have to understand, if this is a building, the first thing you'll mark is this 90 degree. I don't know, they are given the diagram, not given, but you have to understand, definitely the building is perpendicular to the ground. That's no doubt. Okay. So Amal from the window A here and Sumit at the window is here. Observe a vertical tree FT located on the same level ground, 50 meters away from the building. So this tree is 50 meters away from the building. Quickly mark there 50 meters. Okay. So from the building to the tree, that is 50 meters. Right. So this on the sketch, you should be able to mark all the information given. From there onwards, you can do the questions. Right. Now, the window S on the top, the window S and the top of the tree are at the same level. T, that is the top of the tree here. S here, that is where Sumita, right? Sumit is, so it's at the same level, right? Now, Amal observes the top of the tree with an angle of depression of 22 degrees. Now, Amal, remember, is at the top of the tree here. So, top of the building here. She is observing the top of the tree. So, from here to the tree here with an angle of depression, how much? 22 degrees. Now, what I tell you, angle of depression is always where you have a horizontal. From the horizontal, you are looking down. So you're moving down. So it's always measured from the horizontal, right? Elevation is moving up, depression is moving down. Right? I'll mark two angles. Tell me which is the angle of depression, right? Now I'll mark here. Amal, is this A here, angle of depression, or B here, the angle of depression? Yes, quickly answer, A or B.
B. B.
B.
Anyone says
B, sir.
B.
B? No A. Sure? Everyone sure?
Yes, sir.
B is the answer.
Yes, sir. B.
Sir. Yes, sir.
Oh, B. Okay, fine. B might be the answer, right? Yes. Right, how is the connection now? Is it the same like before? Is it better? Ayan? No, okay. I just saw a message. How's the connection, guys? Is it the same thing or is it? Is my board clear? Am I clear?
Okay, sir. Yeah, clear, sir. Clear, sir. Yeah, clear.
Okay. So then, yes, good. Remember what we said? Angle of depression measured from the horizontal. Amal is up here A. This is her horizontal. Moving down, right? From the horizontal, she's looking at the top of the tree. This is the place where she looks at the tree. So then here, this is the B is the angle of depression, right? So that is, they're saying you 22 degrees, right? The angle of depression there is 22 degrees. Okay. All right. So now we have marked all the information on the diagram. Right. Now we have to, I'll just give you an idea on what is, on how to apply trigonometric ratios. Right. Quickly, brace yourselves. I'll give you a quick skim through, not much in detail. Right. Now remember, trigonometry is used for only for, first of all, right angle triangles. Right. Trigonometry can be applied only for right angle triangles. That is the first thing that you must know. Second thing, now, usually, you know, for right angle triangles, we apply another theorem. Can someone quickly tell me what is that?
Pythagoras.
Pythagoras theorem, right? Now, usually trigonometry is used. Now, why do we use trigonometry? Either to find angle or to find sides of a triangle, right? Now, to find sides, we already have Pythagoras theorem, right? You know Pythagoras theorem. You have a right angle triangle, A, B, C. What is Pythagoras theorem, everyone? Quickly tell using ABC.
A square plus B square equals C square.
Side. We always relate side to Pythagoras. What is it?
Plus BC
A
squared
B
is
square
equal
plus
to
C
hypotenuse
square
is equal to
equals
the
AC
other
square.
two sides of
Very
the.
good. Square of the hypotenuse is equal to the sum, addition of square of the other two sides. In other words, AC squared, right? So square of the hypotenuse is equal to the addition or sum of the square of the other two sides. So that is AB squared plus BC squared, right? That is your Pythagoras theorem. Now, usually Pythagoras, you can see it's an equation, right? In the equation, you have three unknown terms, so three terms here. So at least you need two terms to find out the third term. You can see here, equation, three terms, at least two terms. Any of these two terms should be known to find the third term, right? Now, what if there is only one term? How do you find the remaining two sides, right? So in that case where you can't apply Pythagoras and when there is an angle involved, a right angle triangle, where you can't apply Pythagoras because you have only one known value of a side, like this question here. See here? Now, if this is 90 degree, can someone tell me what is the angle here, everyone? What is the
90.
angle here? 90. Why is that?
90
Can
degrees.
someone tell me why is it not 90?
Corresponding angles.
Parallels.
Corresponding angles. Very good. See here, this is also horizontal line. This is also horizontal line. Both are parallel. So they put corresponding angles. If this is 90, this also must be 90 degrees. Right? Now, if you look at this triangle here or look at this triangle, any of the triangle here, you can see there is only one side, 50 meters given to you, right? So using these 50 meters, now in the question you'll see, we are going to find out the other sides of the right angle triangle, right? So in that case also, and also you can see an angle is involved, we'll see how we relate the angle. So in that cases, we involve trigonometry, okay? Right. Now, trigonometry again, for a right angle triangle, there are three ratios you must know, right? If you take a right angle triangle, there are three ratios you must know in trigonometry. If you don't know this, you can't do trigonometric questions, right? Because this is the basic of trigonometry, right? Now, you always, right angle triangle means you always have a 90-degree. Apart from that, you have two more angles here, right? Now, depends on what angle you select to apply the ratio, right? Your opposite, there are three sides. I'll tell you what are three sides. Depending on what angle you choose to apply the ratio, your three sides will have different meanings apart from one side, right? Now, your hypotenuse is always the side opposite to the 90-degree. That will never change, right? This is called your hypotenuse. Whatever, right? Spelling might be wrong. Can't remember also, right? Hypotenuse, right? Now, let's say I know this angle. This angle is known for me, right? If I know this angle, now what happens? This side here, the side opposite to the angle becomes the opposite side, right? The side opposite to the angle becomes the opposite side, and the side next to the angle, this is the angle, the side next to the angle here becomes your adjacent side. Adjacent means next to, right? So you have three sides, right? So then if you know this angle here, in related to this angle, this side is opposite and the side next to it is called adjacent. Hypotenuse will never change. Let's say I know this angle. Angle of this value is given to me, right? If this angle is given, let's mark it X here. Okay. Can someone tell me, according to X, what is my opposite side? Quickly.
CBC.
Very good. CB or BC. Opposite to the angle here. Now this becomes my opposite side. And AB here, the side next to the angle becomes the adjacent side. So depending on what angle you apply the ratio, your opposite and your adjacent side will differ. Right? Now, why is this important to know what is the opposite side and what is the adjacent side? Because the ratio depends on the opposite and the adjacent side. Right? What are the three ratios? You have three ratios, right? One is sine, right? Now, according to the angle, let's say this angle, we select the theta angle here, right? So sine of theta, sine means what? The sine means opposite over the hypotenuse side, right? So sine of theta means relevant to theta, the opposite side. Now here, that is AB divided by the hypotenuse, that is your AC. Right now, I'll write first of all, the sine theta is opposite over hypotenuse, that is AB over AC. Right? Cos theta, right? Now remember, cos will be adjacent over hypotenuse, right? If you take this angle theta here, the angle, the side next to the theta, that is your adjacent, I'll write A here over hypotenuse, right? That is your cos theta. Now in this triangle here, the adjacent BC over AC. Finally, you have another ratio, that is your tan. Your tan theta is opposite over adjacent, right? Opposite over adjacent. So that is AB over BC, right? Now, the basic thing you have to know regarding trigonometry, the three ratios. Whenever you have a right angle triangle, any of the angle that you know here, according to the angle, you have to figure out, right? When you're applying the ratio, let's say I'm applying the ratio for this angle here. For this angle, if I'm applying the three ratios, yes, sine of theta, cos of theta, tan of theta. For this angle, I'm applying the ratio. You must know what is the opposite side. You have to figure it out, and what is the adjacent side. After you figure out the opposite and adjacent, hypotenuse is easy. opposite to the 90 degree, that's your hypotenuse. Then after you figure out the three sides, you have the sine theta, cos theta, and tan theta. Right? Now you ask me, do you need all the three ratios? No. According to the question, you will apply the relevant ratio. Right? Now, for example, let's say in this 90-degree triangle. Now, I told you already this angle is known. The angle is known. Let's say they give you the opposite side is unknown. Right? Let's say the opposite side is equal to x here. And you know the hypotenuse. Let's say hypotenuse is given as 20 meters. Right? Now the opposite side is unknown. Hypotenuse is given. You know the angle. Right? Tell me, out of these three ratios, to find the opposite side, what is the ratio that you will choose? Is it sine, cos, or tan?
90.
Yes? Sine,
Sine.
cos, or tan?
Sine.
Very
Sine,
good. Right? So you look at the diagram and you see, right, what is the two sides which are involved. Now you can see always two sides are involved. What are the two sides involved in relation to the angle? You know the angle, always related to the angle. You know the angle here, right? X here, the unknown side is the opposite. The known side, that is your hypotenuse. So you have to relate the opposite and the hypotenuse. Out of these three ratios, opposite and hypotenuse is related to sine theta. So we are going to use the ratio. What? You can write, let's say this angle is given 40 degrees. So now you will write sine 40. Angle is known now. Theta is 40. So sine 40 is opposite over hypotenuse, x over 20. Right? Now, these values of the ratios are known. Right? You have a table to find out the values of these ratios. Any sine, any cos, any tan, you have to know how to use the trigonometric table. Right? By using the table, we can find out the values of sine values, cos values, or tan values. So this value can be figured out using the trigonometric table. Now what you can do, to find the value of x here, you cross multiply. X will be equal to sine 40, which we can find using the trigonometric table, multiplied by 20. Using that, you can find the value of x here. Is that clear, everyone? Yes. Now, using your trigonometric table is same like using your logbook, right? Only for cost values, there's a bit of a change. If you come across it, I'll teach you how to find cost, how to use the cost table. But apart from that, using sine table and tan table is the same thing, right? I'll just go through briefly when we need it, right? Now we use this knowledge here to apply to these questions and answer, right? We'll see how we can apply, right? Now, if you take the B A part, copy the figure into your answer script and include the given information on it. We have done that. B part. By using the trigonometric ratios, do the following calculation. Find the height SA between the two windows. They are first of all, they are telling you to find this height SA here. Right. Now, for you to find the height SA, definitely you have to use trigonometric ratios. Why? Because you have only one known side, right? Can someone tell me, if this is 50 meters, what is the length of TS here?
50
meters.
That is also 50. See here, the same horizontal line, this is also 50 meters, right? Now, to apply trigonometric ratios, you are going to take this right angle triangle, TAS. Now, we know one angle. We have to find AS, remember, or SA. Right? Now we know this TS value. We know one angle that is outside the triangle. Maybe by using the knowledge of parallel lines, we can find the angle related to the inside this triangle here. Right? Now you know this also horizontal line. This also horizontal. Both of them are parallel. That is a parallel lines. Right? So then, using the knowledge of parallel lines, tell me if this is 22 degrees. What other angle is equal to 22 degrees?
ATS.
ATS, very good, right? So ATS here, alternate angle, this angle here, from this horizontal, see here, from this horizontal looking up, this angle here, that is 22 degrees, right? So now in this right angle triangle, we know one side, we know an angle. Now we can apply trigonometric ratio. Now see here, we need the side AS here, right? We know this angle. Can someone tell me, if you take this right angle triangle, the side AS, is it adjacent, opposite, or hypotenuse?
Opposite.
We learned this angle here.
Adjacent. Adjacent.
You have this angle, look carefully. You have the triangle like this, right? This is A, this is S, and this is T. 90-degree angle, right? They have given this is 22 degrees and this is 50 meters. Right. Now we need to find, see here, you have a known side. This is the side that we need to find out, the unknown side, and you have the angle. In related to the angle, tell me this unknown side, is it opposite, hypotenuse, or your adjacent side?
Opposite.
Opposite.
You can see here, this side here is right opposite to the angle. So that is your opposite side. Now 50 meters, that is your known value. Is it opposite? Now opposite also already gone. Is it adjacent or hypotenuse?
Adjacent.
Definitely adjacent. So you can see here, what are the two sides we are relating? We are relating the opposite and adjacent side. Right. Any ratio out of those three ratios, then what is the ratio that we use to find this opposite?
Tan,
Is it
sir.
sine or tan? Definitely tan. Why? Because tan is opposite over adjacent. Now we can use B part Roman number 1. We can say tan 22 degrees. Right? Tan of this angle is equal to the opposite, that is AS, divided by the adjacent, that is TS. Right? AS divided by TS here. Right? Now we can find this tan 22 using the trigonometric table. This TS value is known, given in the question. Then if you cross multiply here, you can find the value of SA. Right? Now, using your trigonometric table, quickly take it out if you have it. Right? Find the value of tan 22. I'll quickly just go through on how to use the trigonometric table fast. Right? Now, if you take your trigonometric table, like, be very careful of the topic heading, because now you have three tables. You have the logarithm table, right? You have the sine table and you have the tan table. Three tables in your oral paper. So always when you're using the table, look at the heading. That is the first thing you're going to do, because most of you guys mix up the tables and then you figure out the value. The value is wrong and you continue in the question in vain, right? So always look at the topic of the table. Make sure you get the tan table. After you get the tan table, right? The tables are almost similar. That's what I'm telling you. Right. Now, if you take the table here, on this side, you will have your angles. If you see, they are starting from 0 degrees, going all the way up to 89 degrees or 90 degrees. Okay, so you can find from 0 to 90. Right. Now, remember, now when you take measuring length, there is centimeters, meters, kilometers. Right. So likewise, different units to measure length. Right. So likewise, to measure angles also, you have different units. Now, one you know already, that is degrees. Another one that is called minutes, a smaller version of degree. I mean, a smaller measurement of angle. That is 1 degree. Remember, 1 degree is equal to 60 minutes. Okay, so 1 degree can be further divided into 60 minutes. Okay, so then here you have the degrees, and top here you have the minutes in what? In multiples of 10, right? So that is 0 minutes, 10 minutes, 20 minutes. Likewise, in multiples of 10 until 60 minutes, right? After that, there is another column here called the mean difference, right? There's something called the mean difference. In the mean difference column, you have the minutes in ones. That is 1 minute, 2 minutes, 3 minutes, 4 minutes. Likewise, up to 9 minutes. Same like the log table, right? Now, for example, now here we need to find the value of tan 22 degrees. No minutes at all. 0 minutes. Okay. So what do? Take your tan table, come to 22 degrees, right? And 0 minutes. 22 degrees, 0 minutes, then you find this value here. I'll just go through other values that you can find. Let's say, for example, you need 22 degrees and 15 minutes, sorry, let's say 20 minutes, right? 22 degrees and 20 minutes. How do you do? Come 22 degrees on this column here. When you find 22 degrees, right, now you have minutes also. So 22 degrees, 20 minutes here, find this value, that will be equal to tan 22 degrees and 20 minutes. Let's say you need 22 degrees and 26 minutes now, right? So now what do you do? 22 degrees, 20 minutes, you note down the value, right? You just mark a value there to make sure that you know that value. Then you have 6 more minutes, 20 degrees and 6 minutes, let's say 4 minutes, because I have only 4 minutes on the board. So then, but in the same row, find the value of 4 minutes on the mean difference. Same row, 4 minutes, what's the value, right? Now, let's say here the value is equal to 0.4351. And here the value is equal to, let's say, 10 here, for example. Then what do you do? Tan 22 degrees and 24 minutes is equal to what? This value plus addition this value, right? So 4351 plus 10, that is 4361, right? So that is simply how you use your tan table and your sine table. When I come to cos, there's a small difference. I'll tell you how to use the cos table. Okay, right. So now that we know how to use the tan table here, using your tan table, find the value of 22 degrees. So 22 degrees, 0 minutes. Can someone quickly send me the value? What is tan 22?
0.4040.
4040, right? 0.4040. Right. So now we have 0.4040, that is equal to AS is the value, SA, I think the question given you is SA here, divide by TS. TS value we know, that is 50 meters. Now what you do to find the value of SA, we cross multiply 50 into 0.4040. Right. Now, simply what can we do? Now 50 is made up of 5 into 10. Right. So we'll multiply by 5 here. Later we can multiply by 10. So then 0.4040 multiplied by 5. 5 into 0 is 0. 5 into 4, that is 20. 2 into 5 is 0 plus 2. 4 into 5 is 20. 2 here. 0 into 5 is 0 plus 2. So 2.02. Don't forget, we have to multiply by 10 here. To multiply by 10, move the decimal point once here. So now decimal point is here, you have 20.2. So SA is equal to 20.2 meters. Okay, SA is equal to 20.2 meters. Any doubt here, guys? Any doubt here?
No, sir.
All right. All right, next one.
No,
The length of wire drawn from the window to the foot F of the tree is 60 meters. So then from the window A here, they are drawing a wire and connecting to this point F here, right? The length of that wire is now given as 60 meters. Right. Now the question is, find the magnitude of the angle between AF and AB. Sorry, AB here. AF and AB. They want you to find this angle theta, right? I'll quickly just draw a sketch on this side. This is A, this is B, and this is F. They are given this is 60 meters. In the question given to you, this is 50 meters. They want you to find this angle theta. Right. Now quickly tell me what is the ratio that I will use to find this angle theta. You have the angle. Can someone tell me FB? Is it opposite, hypotenuse, adjacent? Which one is it?
Opposite.
Definitely the opposite. You can see here FB opposite of the angle. Opposite. What is this AF here?
Hypotenuse.
Hypotenuse. So can someone tell me opposite, hypotenuse? What is the ratio?
Sine.
Sine. So we are going to use the ratio sine theta. We don't know the angle theta. That's what you are going to find is equal to opposite, that is 50 divided by opposite over hypotenuse, 50 over 60. Right? That is sine theta. Right. So now sine theta, find the decimal value, because in your we are going to use the table again, right? We need a decimal value to find out the angle, right? So now using the table, you can do two things like the logarithms. Okay, you can find the ratio value, that is, let's say you know the angle, right? Like tan, like 22 degrees here. You can find the ratio, that is tan 22. You can find the ratio value, or if you know the ratio value, you can find the angle. Now here we know the ratio value, we don't know the angle. So using the table, by using the ratio value, we are going to find the angle. Okay. So now we have to divide 5 by 6. We'll do the division. We have to get at least 4 decimal points, right? So 6 divided by 5. So first of all, that is 0, right? So then add a 0 here, that is 50. 6 into 8 is 48. Remainder is 2. Right? Add another 0, 20. 6 into 3, that is 18. Remainder 2. Add another 0, again 3. So it will keep on repeating like that. We'll add one more 3 to keep on dividing. Still you get another 3. So sine theta is equal to 0.8333. Right? Now what do we do? Before we knew the angle and we found the ratio value. Now we are going in reverse. We are going to go in reverse. We know the ratio. So we figure out in the table there, do we have a 0.8333? Right? So now, if you have a 0.8333 directly, things are easier. You can directly get the answer. Right? But if you don't have a 0.8333, what do? Make sure you get the correct table. Your sine table. Now we are using sine, not tan. Right? So then if you don't have a 0.8333, we get to the closest value. And remember, closest lower value, not a higher value, right? Closest lower value to 0.8333, right? So can someone tell me, do you have a closest lower value to 0.8333?
Yes, sir.
What is it?
Yes, sir.
0.8323.
Very good. 0.8323. That is the closest value you have to 0.8333. Right? So now I don't have space here. I'll do it here, right? So you have a 0.8323. Right? Now note down the relevant angle there. What is the angle? 56 degrees. The row is the angle, and the column will give you the minutes in multiples of 10. Right? So that is 20 minutes. But what we need is 0.83333, not 0.8323. Right? So in that case, check how much more. If you add here, you will get 0.8333. So from 23 to 33, you can easily see you need to add 10 more. Then what do? In your mean difference column, in the same row, you check whether you have a 10. Yes, you do. You have a 10 there. What is the relevant column? Right? So the relevant column, that is 6 minutes. So now see here, now you can find out the angle. So this is 0.83333. So 56 degrees, 20 minutes plus 6 minutes, that is 26 minutes. Right? So the angle theta here is equal to 56 degrees and 26 minutes. Is that clear, everyone? Is that understood?
Sir.
Yes? Okay.
Yes.
Right.
Excuse me, sir.
Yes?
So that's angle FAB, right?
Angle FAB. Yes, this angle here.
Okay, sir.
Okay. Right, last one. Roman number 3. Give reasons why FB is greater than AB. Give the reasons why FB is greater, right? Why this length is greater than AB. Now here, when they tell you to give reasons, you're not going to calculate or anything, right? Using the angle value, using some ratio out of the 3 ratios that you know of, you're going to give a reason why this value is greater than this value. Right. Can someone think of something? Yes, how are you going to give the reason?
I-
By comparing the angle.
Pythagoras.
Pythagoras, no, I told you, don't use calculation. You can't use calculation, just giving reasons. Any other way?
So by comparing the angle.
By comparing the angles, what angle?
BAF and AFB.
BAF and AFB. Okay, comparing the angles, what are you going to say? Yes, what will be your reasoning? Tell me the reasoning. So because this angle is greater than this angle, this length will be less than this length. Is that the reason?
Because the opposite is bigger than the alternate.
Opposite is bigger than the adjacent, right? Now here, the easiest way to do this is by, now see here, they're telling you to compare this and this, right? They're telling you to compare this value and this value. Why? FB is greater than AB, right? Now tell me, what is the ratio that will relate FB and AB relate to this angle here? What ratio out of the three?
And
Tan 56, right? So tan 56 will give us the idea, right? So now you can write tan 56 degrees and 26 minutes is equal to FB over AB, right? So tan 26 degrees and 56 degrees and 26 minutes is equal to FB over AB, right? Now here you have to know one point, right? The point is you have to know tan 45 is equal to 1, right? So now you're going to say, you have to know this, right? Tan 45 is equal to 1. Tan 45 means when the opposite side and the adjacent side are equal, right? So when opposite and adjacent are equal, then that is equal to tan 45. Now you will say tan 45 is equal to 1. So then tan 26 degrees, 56 degrees and 26 minutes. What can you say? Definitely tan 56 degrees, 26 minutes is greater than 1. Right? So we know by value tan 45 is equal to 1. Right? Now also we know tan 56 degrees 26 minutes is equal to FB over AB. And also definitely tan 56 degrees 26 minutes is greater than 1. Now if this is greater than 1, what tells you about the numerator and denominator? Which is greater? Now if a fraction is greater than 1, what is the idea that gives you? Is the numerator bigger or denominator bigger?
Numerator.
Definitely numerator is bigger, right? So now you will tell, so therefore FB over AB is greater than 1, right? If tan 56 degrees 26 minutes is greater than 1, then this FB over AB is also definitely greater than 1. If that is greater than 1, the final conclusion that you will make, I'll write it here, right? So this is the first thing you're going to write. Then you're going to write tan 45 is equal to 1. Then you're going to say tan 56 degrees and 26 minutes is greater than 1. Then this fraction is greater than 1. So finally you can say the fraction is greater than 1. Definitely the numerator, that is FB, it should be greater than AB. Is that clear, everyone? Yes?
so if tan 56 means 26 degrees, sorry, if FB over AB is greater than 1, how does it show that FB is greater than AB?
Okay, now let's say I give you an idea like this. Whenever you have a fraction, right? Whenever you have a fraction, for a fraction, now if both of them are equal, let's say 20 and 20. If both numerator and denominator is 20 and 20, what will be the fraction value? Who asked the question? Yes, what will be the fraction value?
1.
Well, fraction is equal to 1. Now, let's say I keep this, I don't change the denominator, I increase the numerator. Let's say I make this 30, right? Now what happens to the fraction value? 30 divided now, 0 and 0 cancel, 3 divided by 2, that is equal to what? 1.5. So if you take any fraction, if the numerator is greater than the denominator, then definitely the ratio or the fraction value, now when you divide and get the decimal, that's called the ratio. Right? Remember, ratio and fraction goes very close to each other. right? Now, if you write the fraction in the decimal value, that's a ratio, right? If you write the fraction in terms of numerator and denominator, it's a fraction, right? So if this value, the ratio value is greater than 1, then definitely the numerator is greater than the denominator. Is that clear?
Yeah, sir. Thank you.
Sure, Yusri.
Yeah, sir.
Okay, fine. Right? So we can say that the other way around also. If the ratio, if the fraction value is less than 1, so what can you say? Then at that place, the denominator will be greater than the numerator. Okay? Goes both the ways. Right. So now remember, trigonometry, I didn't teach you everything. Right? It's not a theory class, right? But most important ones. Now, definitely to do any question, you need to know these three ratios: sine, cos, and tan. The next thing, you need to know how to use the table, the sine table, the tan table, and now remember, to find cos values, you use the same sine table. Okay, so you have to know how to use the table, right? Now don't think this is this simple. No, you have to know all the theory, right? I don't have time to teach everything, right? So then you have to know all the theory, right? But then to do the question, you see how only few things are needed. But what I told, definitely these three ratios, you have to know what these three ratios mean and how to, minimum, basic level, how to use the trigonometric tables, all the three tables. Is that clear? So those are the minimum requirement you need in order to do the question. And you have to know all everything regarding vertical angles. The only thing you have to know regarding vertical angles and how to, on what is elevation, angle of elevation, and what is angle of depression, right? Other than that, things are very straightforward. The lengths are not difficult, right? Okay, next question, right? Chamara and Amal. Can you draw the diagram? Right. So this is the diagram given to you. Now probably you have to read the question and mark the information on the diagram. Right. Now, Chamara, that is C, and Amal A are standing on the level ground. So this is the horizontal ground, right? On opposite sides of a vertical tree, KT. So you have a vertical tree. On opposite sides, Amal and Chamara is there, right? As shown in the figure. Amal, which is A, is 30 meters away from the tree. So quickly mark there. They are 30 meters away from the tree. Now remember, diagram given to you, you have to always, now you might say, sir, the tree might be crooked, not exactly perpendicular, but you get the idea, okay? For you to apply trigonometry, definitely the tree should be perpendicular. Did they tell that to you? So you're not given, but take the tree as perpendicular, otherwise you can't apply trigonometric ratios, right? Now, see, they are 30 meters away and Chamara is flying a kite. So this Chamara man is flying a kite here, right? So this Amal is 30 meters away from the tree. Now what happens? The kite suddenly gets entangled at the top of the tree here. So now the kite is at the top of the tree, right? And then such that the string is taut. Taut means a tense string, right? The opposite word of taut is slack. So slack means the string has no tension, right? It's just sloppy. So a taut string is a very tight string, right? Where there is tension. In other words, what they're trying to say, the string is a straight line, not a crooked line, right? So this is a straight line here. So the kite is here. This man is pulling the kite. This is Chamara pulling the kite. So then the kite, the string is a straight line, right? The string is 40 meters long. So from the top of the tree to Chamara, that is your string, that is 40 meters long, right? Now, at the moment, Chamara sees the kite. So Chamara is here. Okay, so that angle here, I'll mark it like this. This angle here is 44 degrees. And Aman, copy the diagram on your answer script and include the information. We have done that, right? Roman number 2. Find the height KT, right? You have to find the height of the tree KT here, right? Now, you know, like remember, for you to apply trigonometric ratios, minimum, the lowest thing that you need is at least you need one side of the triangle. Now, you know, in a triangle, you have 3 sides, right? So at least one side of the triangle must be known, and at least one angle apart from the 90 degree, one of these angle must be known for you to apply ratio, trigonometric ratio. Now, looking at the diagram here, in order to find this KT, either we can use this right angle triangle or we can use this right angle triangle. Now, with the information given, tell me, can I use the KCT or can I use KAT? Which triangle can be used to find KT?
KCT.
KCT triangle. Why? There only you have one side and one angle. In this triangle, you have only one side, no angle, so you can't apply trigonometric ratios, right? So we are going to apply trigonometric ratio to this triangle, this right angle triangle. Now, looking at the triangle, can someone tell me? See here, this is the angle. The side that we need, the unknown side is KT, and the known side is KC here, right? So KT to this angle, is it opposite or is it adjacent?
Opposite.
Opposite.
Definitely opposite. KC here, what is it?
Hypotenuse.
Hypotenuse. So opposite hypotenuse, what is the ratio? Sine, cos, or tan?
Sine.
Sine.
Sine. Okay, so here to find the KT value, we are going to use sine of this angle. So sine 44 degrees, 50 minutes is equal to opposite KT divided by hypotenuse, that is KC, right? Now quickly use your trigonometric table and find 44 degrees. Find 44 here. On this column, you have the minutes in multiples of 10. 44 degrees and 50 minutes. Find the value. Can someone tell me? Make sure you're using the sine table, right? So what is the value there? 44 degrees, 50 minutes. Anyone?
0.7050.
7050.
0.7050.
Yes, sir.
Yes. Okay. So we have 0.7050, that is equal to KT. That is the one we have to find. KC is 40 meters. Now cross multiply. KT is equal to 0.7050 multiplied by 40. Do the multiplication like we did before. First multiply by 4, then multiply by 10. Right? So 0.705. Now 0 is not needed. Multiplied by 4. 4 into 5 is 20. 2 here. 0 into 4 is 0. Plus 2 is 2. 4 into 7 is 28. 2 here. 0 into 4 is 0 plus 2. 2.820. Now remember, you have to multiply by 10. To multiply by 10, move the decimal point here. So you have your answer 28.2 meters. So it's a length. So it will be meters. So 28.2 meters. Okay, that is your Roman number 2. Right, quickly, Roman number 3 likewise. What is the angle of elevation with which Amal sees the kite at this moment? Amal is here. They are telling you at what angle does Amal see the kite? Now, Amal here, from the horizontal to the top of the tree here, this angle is the angle which he will see the kite. Okay, you have to find this angle here. Now we know KT. KT is 28.2 meters. Right? Quickly tell me, for this angle, what is this KT? Is it opposite, adjacent, or hypotenuse?
Opposite.
Opposite. You know, you don't know KA. KA is unknown. What you know is AT or TA here. What is that?
Adjacent.
Adjacent.
Adjacent. So what is the ratio you're going to use? Opposite and adjacent.
Tan.
Tan. So in this triangle, we can use tan of this theta. Tan theta is equal to opposite KT over adjacent here, that is TA. Now KT, that is 28.2 divided by TA, that is 30. So then tan theta. We have to find the ratio value. Before we knew the angle, then we could find the ratio. Here now we can find the ratio. We are going to find the angle. So first we have to do the division. See here, 28.2 divided by 3. First divide by 3, then we can divide by 10 easily. Right? 3 divided by 28, we have 9 here. 3 into 9, that is 27. Remainder is 1. Then bring the 2 down here. Place the decimal point. 3 into 4 is 12. Right? Now 9.4 divide by 10. If you divide by 10, move the decimal point this side now. So your answer 0.94. Right? 0.94. But then to use your tan table, you need at least 4 decimal places. You add 0 there. No problem. Right? So then now we can find the tan theta. Use your tan table and find the angle. You see whether you have a 0.9449400. Make sure you're using the tan table, right? So 0.9400, right? You don't have a 0.9400. What is the closest value you have? Yes? 0.9380. 0.9380. The angle there for 0.9380, 43 degrees, and the minutes there 0.8, that is 10 minutes. Right? Now you need what you need is 9400. What you have is 9380. You need 20 more. Right? So in the same row, check whether you have a 20. You don't have a 20, so you get the closest lower value. You have a 17 there. So 17, we take the 17. So that is 3 minutes. Now, can someone quickly read this angle here? What is this angle?
43 degrees and 13 minutes.
43 degrees 13 minutes.
Very good. 43 degrees and 13 minutes. Okay. So that is the angle.
43 degrees. Yeah.
Yes. Any doubt? You see? You still have any doubt? No, right? Okay, fine. So then that is your Roman number, 3. Finally, usually the last question is a reasoning question. We'll see what are they asking for. With reasons, state which of the two, Chamara or Amal, is standing closer to the tree. Right. Now use your life experiences here. Right. Now, when you stand closer to a tall object, let's say a building, right? When you stand closer to a building, do you raise your head more? Or when you stand far away from the building, you raise your head more? In which scenario do you raise your head more?
Closer to the building.
Definitely closer to the building. So the person closer to the tree here will have a larger angle looking at the top of the tree, while the person far away from the tree will have a lesser angle looking at the top of the tree. Is everyone understanding that? Got that idea? Yes or no?
Yes, sir.
Yes. Okay. Now comparing the two angles, here you have 44 degrees 50 minutes. Here the angle is 43 degrees and 13 minutes. Can someone tell me who is standing closer to the tree? Is it Amal or is it Chamara?
Charm.
Chamara.
Chamara or Amal? Oh, yes, Chamara. Right, good. Larger angle, right? So how can you answer this? You can tell 44 degrees, right, and 50 minutes is greater than 43 degrees and 13 minutes. That's the first statement you're going to make. Right? Only two things. Therefore, you can say Chamara is closer to the tree than Amal. That answer will give you the full marks. Is that clear, everyone?
So if we find the distance and say, then is it wrong?
Now that is an extra work. You don't need to do that. Right? Now, I don't know whether they give marks or not. I can't assure you that. That depends on the marking scheme. Right? Not sure. I mean, they can't not have a reason to not give you marks. But at the same time, what they expect you from this question is to see whether you can make this connection. Is that clear? Yes?
Yes.
So I can explain again that part.
Sorry?
Can I explain how you found the least amount of?
Yeah, okay, I'll explain using two methods. So one is this practical method, right? I'm just asking, generally when you look at a building, when you're closer to the building, you raise your head more. That means the angle of elevation is more. When you're far away from the building, right, you don't raise as much as you're close by, right? So let's say you look at a far away building, you just, even with the horizontal, a little bit of elevation, you can see the top of the building. But when you're very close to the building, you have to raise your head like this to see the top of the building. So using that logical idea, what can you say? Larger the angle, closer the person to the building. So the larger the angle here, Chamar has an angle of 44 degrees 50 minutes, while Amal has an angle of 43 degrees 13 minutes. So he has a larger angle, then this person must be closer to the building than Amal. That is one way to think of. Is that clear, Yusri?
Yeah, sir.
Okay. Now the same thing, same idea, I can explain using tan. See here, I can tell tan 45 is equal to 1, right? Oh, don't need tan 45 here. No, tan 45 value not needed, right? So you can say tan 44 degrees and 50 minutes, right? Tan 44 degrees and 50 minutes is definitely, see here, is definitely greater than tan 43 degrees and 13 minutes. Do you agree here? Tan 44 degrees and 50 minutes is greater than tan 30 degrees and 13 minutes. Now, what is tan 44 degrees 50 minutes? That is opposite over adjacent. This is the angle I'm relating, right? Opposite, KT over CT, right? So KT divided by CT is greater than, what is tan 43 degrees? Again, KT over 80. KT over 80. Right. Now see here, right? Look at the value. KT and KT, both the numerators are the same, right? So numerator is the same. Now we have to compare the denominator. Right. Now, if I ask you, right, in a fraction, when the denominator reduces, what happens to the fraction value? Let's say the numerator is the same, numerator is not changing. When the denominator is reducing, what happens to the ratio or the fraction value? What happens? Does it increase or does it decrease?
Decrease.
Again, now let's say
Decrease.
you have 20 here, 20 divided by 5 and 20 divided by 4. 20 divided by 5 and 20 divided by 4. Which is greater?
20 divided by
20
20
divided by
divided by
4.
Come on, guys. 20 divided by 5 or 4?
4, sir.
4.
4. 20 divided by 5 is 4. 20 divided by 4 is 5. So what can you say here? When the denominator is reducing, the ratio or the fraction value is increasing, right? So when the denominator is reducing, the fraction value is increasing, right? Now we'll apply the same knowledge here. Now here, the fraction value is greater. What does that mean? Numerator is the same thing. Numerator is the same, but the is greater if the fraction, that means AT should be greater than CT. Is that clear? Did I mess it up? Wait, KT over CT, KT over AT, fraction value is greater. So who is far away? They're asking who is closer, who is far away.
Closer, sir. Yeah, correct.
Closer, correct, right?
Close.
So
Correct,
CT,
sir.
right? AT is greater than CT. So this length here is greater than this length. In other words, this chamfer is closer to the tree. Is that clear, everyone?
Yes.
Yes,
You
sir.
can use this logical method or you can use this tan value. This will be a much better argument, this using this tan method. Like I prefer this method, but I think this also would give you a full mark. Right. Last one, 2024.
So don't erase that tan.
Okay. I quickly draw the diagram. Right. Now read the question. This is a diagram given to you. In a competition, the competitors had to run up a inclined plane, then climb up a vertical ladder, and then slide down another inclined plane. Right? The side view of the two inclined planes and the vertical ladder used for this are denoted by AC and DE. Those are the inclined plane, and CD is the vertical ladder. So what should the competitors do? They should climb this inclined plane, climb the vertical ladder, then come down this inclined plane. Right? Okay. Here, ADE is a horizontal plane. Fine. AC is equal to BE, that is 50 meters. Right? AC is 50 meters and BE is also 50 meters. Right. Here, and CAB is 26 degrees and 10 minutes. CAB, this angle, 26 degrees, 10 minutes. Right. Now, BCD is a perpendicular to AEB. BCD is perpendicular to AEB. So 90, 90 on both the sides. Then they have finally told you DC is equal to BC. So these two lengths here, these two are equal in value. Right? So you have to mark this on your diagram. Copy the figure in your answer script and include the information. We have done that already. Using the trigonometric ratios, show that the difference between the incline that of DE, that is the DEB, this angle here, and the incline of AC, that is CAB, that is this angle here, is more than 15 degrees. So they are telling you to show this angle is 15 degrees more than this angle, right? So to find the difference, definitely you have to find this angle here, right? So that will be the last question, last thing you are going to do using the ratio. You have to find that angle, right? Okay. Now we start working backwards. If you need this angle, now you have one value, right? To find an angle, now you know any three ratios that you take. I'll take an example. Sine theta is opposite over hypotenuse, right? Now, if you know the angle, I told you, you need at least one angle, one side. One angle, one side to find the other, any of the other side, right? Same thing, if you need to find the angle, you can see, you need the values of two sides, right? Opposite over hypotenuse. Let's say if you are using the other ratio, cos, you need adjacent and hypotenuse. If you are using tan, you need opposite and adjacent. Anyway, idea is, if you need to find an angle, you need two sides of the triangle, right? If you need to find this angle here, either you need, now you have one side, you need one more side, either this side or this side. Anything is fine. Now, looking at the diagram, you can see finding this side is not possible. But finding this side, because this side is connected to this triangle, maybe we can do something here and find the length here, right? So if you need to find this angle, you need to find this length first of all. If you need to find this length, we are going to use this triangle here, right? Now in the question they have given you, these two lengths are equal in value. That means if you find this length, you know the value of this length as well, right? So the idea is to find this length. Now, using this triangle, we can find this length. Why I'm saying you? Because we know one side of the triangle, we know one angle. I told you one side, one angle known. We can find another side of the triangle, right? Now using this triangle here, this is the angle that we know of. Now we can find this side. If you find this side, that will be equal to this side. Then we can find this angle here. That's the plan, right? Now this is the side we have to find out. We know what is this 50 meters? Opposite, adjacent, or hypotenuse?
Hypotenuse.
Hypotenuse. To this angle, we know this angle. I'm relating to this angle here. To this angle, what is this side? BC. Opposite or adjacent?
Opposite.
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 And what is the ratio we use? We need opposite and hypotenuse. So what is the ratio?
Sine.
Sine.
Very good. Sine.
Right.
Right. So we are going to use sine 26 degrees and 10 minutes. That is equal to BC over AC. Right. Now using your sine table, quickly tell me what is the value of 26 degrees and 10 minutes?
0.4410.
1 0.
0.4417.
10.
10. So 0.4410. Is it correct?
Yes, sir.
Yes, that is equal to opposite BC. That is the value that you need to find. BC over AC, that is 50 meters. Now cross multiply to find the value of BC here. BC is equal to 0.4410. Don't need to put. Multiplied by 50. So first we'll multiply by 5 here. 0.441 multiplied by 5. So 1 into 5 is 5. 1 into 5 is 20. Sorry, 4 into 5 is 20. 4 into 5 is 20 plus 2, 22. 2 here, place the decimal point. 0 into 5 is 0 plus 2. So 2.205. Don't forget we have to multiply by a 10 here. If you multiply by a 10, what do you get? Move the decimal point once here. 22.05. Okay, so 22.05. Now we know this value 22.05. Then we know BC is equal to CD. Then you can write here, right? See, BD, this total length is equal to 22.05 multiplied by 2. Because this 22.05, you multiply by 2, you get 44.1 meters. Okay, that is the side BD here. Now what you can do, you know this side BD, you know BE here, then to find this angle, relate to this angle, what is this side BD here? Opposite or adjacent?
Opposite side.
Opposite. What is this BE?
Adjacent.
Adjacent. Opposite and adjacent, what is the ratio?
Tan.
Theta.
Tan, right? So now we can use tan here. Tan theta is opposite, that is 44.1 meters, divided by adjacent, that is 50 meters, right? So better, now here, better to write the English alphabet first. So BD over BE, right? So 44.1 divided by, yes, 50 meters. Okay. Now we have to do the division. Find the ratio value, then only you can find the angle, right? So now we'll do the division up here. 44.1 divided by 5. We'll divide by 10 later. 5 into 8 is 40. Remainder is 4. Bring the 1 down. Place decimal point. Again 5 into 8, that is 40. Remainder is 1. Bring another 0 down, that is 10. Now 5 into 2, that is equal to 10. Now again what do? You divide by 10. So 8.82 divided by 10. Move the decimal point once more. So you have 0.882 and another 0 there. So tan theta is equal to 0.8820. Okay. Now using the tan table, we can find the value of theta. Get the closest value to 0.8820. Make sure you're using the tan table, not the sine table. Right? So 0.8820. Do you have a 0.8820?
0.879.
No, right? So then the closest value you can get is 0.8796. Right? You have a 0.8796. Right? How much more you need? You need 24 more. Right? You need 24 more. Now this is 41 degrees. How many minutes? 8796, that is 20 minutes, right? Now you need 24 more. Do you have a 24 there? The closest one is 21. We'll take the 21, right? So 21, how many minutes is that? 4 minutes, right? Now what is the angle here then? 41 degrees, 24 minutes, right? So the angle here, that is 41 degrees and 24 minutes. We are not done yet. You have to show the difference is more than 15 degrees, right? The difference is more than 15 degrees. Now simply we just have to subtract to find the difference, right? Now what we can do, 41 degrees 24 minutes minus 26 degrees and how much? 10 minutes is equal to what? Right? We'll do the subtraction of here, 41 degrees 24 minutes minus 26 degrees and 10 minutes. So 10 from 14, so 24, that is 14 minutes. 26 from 41, that is 15 degrees. Okay, so now we have 15 degrees and 14 minutes. So they told you to show it's greater than 15. So you can tell 15 degrees and 14 minutes is greater than 15 degrees. Is that clear, everyone?
Yes, sir.
Any doubt here? So this is only regarding vertical angles, right? Maybe next class we'll be discussing regarding horizontal angles. The concept is the same, right? Only the way that we measure the horizontal angle is different. Now here we measure horizontal angle using called angle of elevation, angle of depression, right? Next class you will see we use something called the bearing. You will see how to do it next class, right? Okay, that's it for today. If you have any doubt, you can drop me a message on WhatsApp. No, good night, everyone. Sorry about yesterday, right? A bit unexpected. I honestly didn't hear I mean, the phone is off, honestly. Like, that's all. Right, then, take care.
Excuse me, sir.
Jazakallah,
Yeah.
sir. Assalamu alaikum.
Excuse me, sir.
Jazakallah.
So are we having the next